All right, now this is still in your 8-2 in your book, and your goal for today is to be able to use our sine, cosine, and tangent ratios. So those ratios that we learned yesterday, so our SOHCAHTOA, S-O-H, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. We're going to use those to play a little game, okay? For right now, for these first few problems, they're going to give us a reference angle. They're going to give us some angle in a right triangle. In other words, they're going to give us one of the acute angles, okay? And our task isn't necessarily to find this guy, although we could if we wanted to, but they're typically going to want us to find a side. So in this case, we need to decide, do we want to use sine, cosine, or tangent to set up a nice ratio? Well, to pick, what we really need to do is play a little game of what do we have and what do we want. So first of all, we need to label the three sides. Okay, there's my hypotenuse. And in reference my little blue angle over here, this guy is the adjacent, and across away from this guy must be the opposite. Okay, and right now we want the opposite. We have the hypotenuse. So that's how we determine which of these we want. Let's see, which ratio has the opposite and the hypotenuse in it? Yes, it is. It's the sine. The sine equals the opposite over the hypotenuse. So what we're going to do is just plug in there. Okay, so we're going to plug in the sine of what angle? Well, in this case, it's the sine of 24 degrees. And your calculator will give you that number. Okay, we're going to take that to 4 places today. Okay, but your calculator will give you that number. The opposite, well, we know that that is x, right? And the hypotenuse is 10.5. Now, this is a ratio. We did all these working ratios in chapter 7. So now I can say, okay, I can cross multiply, right? This is over 1, if you will. And the sine of 24 times 10.5 in my calculator is x. Okay, I'm just going to cross multiply, and x times 1 is x, so x equals, and that number turns out to be, let's see, it turns out to be 4.3. And I'm taking, just so you know, when I took the sine of 24, let's go ahead and if I didn't see all that, how I would write that out. The sine of 24 in your calculator, you're going to take it to 4 places. So 0.4067 equals x over 10.5. Okay, that's the ratio that I just solved. Okay, but hopefully you can do that quickly and easily in your calculator, and life is good. All right. So this side is 4.3, and then we'll move on with our lives. Okay. But that's our skill today. Find missing sides typically. All right. Okay. Again, I'm finding a missing side again here. So from this angle that they labeled, let's go ahead and mark him always. This is our reference angle. And now again, the opposite is over here. This is the opposite. This is the hypotenuse. This is the adjacent. What a great habit to get into, labeling these properly every time. And now, let's play the game of what do I have? What do I want? I have the opposite. I want the adjacent. Opposite and adjacent. Let's see. So if I know my vocabulary, TOA is opposite over adjacent. So the tangent of 65 degrees is equal to the opposite over the adjacent. So the opposite, I know that's 2.3. The adjacent is unknown. Okay, so now this gets a little bit harder. This is basically x times, going to cross multiply the tangent of 65 degrees equals 2.3 times 1. So 2.3. Okay. Well, next step is going to be x equals 2.3. Divide both sides by tangent of 65 degrees, right? Algebraically, you guys all know that algebra. So the tangent of 65 degrees. Okay? So now we're just plugging into our calculator. 2.3 divided by the tangent of 65, and you get a grand total of 1.07. Typically, unless they tell us otherwise, for the sides, we'll go with the nearest tenth, and we'll call this 1.1. Okay? Fair enough? But now, once you do a couple of these, you'll see a pattern. Basically, you'll see if the X is in the bottom, that means you just they just flip spots and then you just divide. Okay, but you have to do a couple of those with practice to see that pattern. Okay, so 1.1 is my X. Okay, does that make sense? Yes, it's shorter than my opposite. That looks to be to scale, so forth and so on. So quick check, it seems reasonable. Now, solving for x. Okay, let's see here. We're going to, again, mark my reference angle. And from that reference angle, this is opposite. This is adjacent. And this is hypotenuse. Okay, so now with reference to that angle, let's see. What do I have? What do I want? Those two. Adjacent and hypotenuse. Ka, right? So the cosine of 20 degrees equals the adjacent over the hypotenuse, which is unknown. Cosine equals adjacent over hypotenuse. Got to know that. Got to know that, right? So now let's go ahead and we can cut to the chase now that we did the previous example and say x equals 17 over the cosine of 20. Just flip those guys. That works, right? That works every time. And then go to your calculator, and 17 divided by the cosine of 20 is 18.09, so approximately 18.1. Does that make sense? Yes, my hypotenuse is longer than my side there, and that looks to be very, very good, and we're rocking and rolling. Okay? All right. Next problem. One more of these, solve for x, solve for an unknown side. Mark my reference angle, mark my sides. You've been doing this for 2 days now, hopefully, so this is good. This is opposite. This is adjacent. This is hypotenuse. And let's see. What do I have? What do I want? Opposite and adjacent. That's TOA. Tangent is opposite over adjacent. So now we just plug in the tangent of 59 degrees equals the opposite that we don't know, the adjacent 11.6. And now these are real nice. When the x is on top, think about this as over 1. We're just cross multiplying. X times 1 equals x. Tangent of 59 times 11.6 is a grand total of 19.3. Does that make sense? Yeah, 11.6, 19.3. And then I could find the hypotenuse if I wanted to. I could use Pythagorean theorem. But the only thing you got to remember when you use these, you're typically rounding when you get these numbers. So you're a little bit less accurate the more and more you use a rounded number. Okay? All right, the last example we're going to use, all these we've been finding sides, okay? Now we're going to use your calculator to find an angle, okay? So you are going to go ahead and this problem here, the interstate is being built from Cincinnati to Youngstown. What angle should the workers head out at? Okay, so they're basically asking you to find this angle right here. So this is the second use of SOHCAHTOA, basically. All right, so in this right triangle, I basically have the opposite and the adjacent. Excuse me, sorry. Adjacent. So that means I must be using the tangent ratio, right? TOA. TOA must be what I'm using. Okay, but in this case, I'm going to do it a little differently. I'm going to say the tangent of some unknown angle, x degrees, is the opposite over the adjacent. And your calculator is so brilliant that you can basically say, do what's called an inverse function on it. Okay? And I'll show you how to do this in your calculator when you get to class. But you're basically, there's a button, you hit second tangent, and you can probably figure this out on your own without me, and say, Mr. Calculator, if my ratio, if I have a right triangle and my ratio of opposite to adjacent is 65 to 261, can you tell me what angle that goes with? And since all right triangles work in this same way with this sine, cosine, and tangent, your calculator will say, well, son, that calculator is going to spit out 14 degrees, 13.98, blah, 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 approximately 14 degrees. So what your calculator is saying is, okay, if you have a right triangle and your opposite versus adjacent ratio is 65 to 261, then this reference angle down in this corner must be 14 degrees because all right triangles are built this way. Okay? And this is pretty powerful. We'll talk about this today, and we'll do some more practice with this. But basically, this is our second skill. Skill one for today was being able, given an angle, an acute angle, and a right triangle, and one side, be able to find another missing side. And skill two is given two sides in a right triangle, be able to find one of the acute angles. Okay? So those two skills, that's what we're working on. And this is really good, important stuff, and we'll work on this in class today. Hope you're having a great day, and we will talk to you soon.